The transmission control protocol, what's its job? Its job is to make sure that the messages get broken down into packets and that they can go all the way around the world and reliably get to the other place. Right now, you're watching me through the power of the internet, and all this video component, every single of these images frames are smashed into millions of these small packets. Each of these packets has to be routed back to an Outlook server or to a Microsoft server and then back out to you guys. And maybe every so often there's a glitch and it looks a bit blocky, and that would be basically because a packet got lost. But nearly all of these millions of packets get to the right place and then get to you. How does that happen reliably? Well, that happens by using the TCP IP protocol stack. That is the steps you go through, the set of rules that need to be followed to allow all this data to get from place to place. There are 4 layers to TCP, so not the IP bit, the TC bit. Application layer, transport layer, internet layer, and link layer. And my tip to you guys was this little acronym here, ATIL. Application, transport, internet, and link. And we're going to have a look about what all those different things do, and then we're going to do a demonstration. Oh, I must have talked about it last time. So these are the 4 different layers. Application, transport, internet, and link, ATIL, like we were just saying. Now, what we have to do is then understand what happens at each of these steps. So, step number 1 is at the application layer. So let's say you're downloading a web page. Well, the first thing that has to happen is that the HTTP or HTTPS protocol has to be attached to it. Let's say you're sending an email. The first thing that has to happen is the SMTP protocol gets attached to it. So at the application layer, it's when those individual protocols you've just learned about get attached. What happens next? Well, next is transport. Transport creates a link between one device and the other device. In the real world, we have physical addresses. In the computer world, we have what? What are the addresses we'll use? So in the real world, if I'm sending a letter, thank you, Josh. Other people, thank you, Brooke. In the real world, if I'm sending you a package, I need, your first line of your address, area, city, postcode. It's the same with an internet address using a packet, except you've got a bunch of numbers that represent your location. So it will take the sender's IP address, the receiver's IP address, and then it creates the link between the two of them. It takes that data, you break it into individual packets, and then it agrees the size of the packets. And do you remember we agreed about this last time? We had a little conversation about it, if I remember correctly, where we looked at this and we said, in the end, data is just a bunch of ones and zeros. But how we split that up into packets, we have to have the same size. So both sides have to agree. Do you remember what we said with the kid sticking his tongue out? If both sides don't agree that that's a way of greeting each other, then it would be considered rude. So a protocol isn't just a set of rules that govern communication, it's that it has to be agreed by both sides. So the receiver and the sender have to apply the protocol in the same way. In this case, splitting up packets has to be the same way around. So it creates the link, agrees the size of packets, break those packets up. Then at the internet layer, each of these packets, like you'd have to send each of your packages, each of them has to have an IP address attached. And then it sends the data through the internet, and it might take a bunch of hops. A bit like, I think I probably used the analogy of driving. When you want to drive from one place to another, at every intersection you could go left, right, it depends. Same deal here with these packets. Every packet could go in a slightly different route. To get from where, to send, a message from, even from me to you guys, it might have jumped over 5 or 6 jumps just to get there. And they all might take slightly different routes, which is why actually the packets need to be numbered. So when they're put back together again. It's why on video it buffers. So that means that if, say, the packets get done in a different order, it can catch up with itself while it's sticking it together, because maybe it's missing one packet of data. Because it's buffered, it can wait for that packet to then come into place and then make it up. And then finally, there's the link layer. The link layer is the physical level of the internet. What do we talk about there? Well, we're talking about Ethernet cables, Wi-Fi cables, network interface cards with their own, remember there's a MAC address. This is where you're taking the logical thing of the internet with the IP addresses and then connecting it to the physical layer. And that's how it works. Right now, I said there was going to be a demonstration, right? Hopefully this will go well. Demonstrations always go so well. I, via the internet, now want to send this. If you're wondering, I did draw it myself. Okay, it's me. Look, a beard. Anyway, this I'm sending over the internet. Let's, in fact, do you know what I'm going to do? Wicked. There you go, a little bit less confusing. So this I'm sending over the internet. What's the first layer that I'll need to apply? Oh, in fact, I can make myself a bit bigger. Can you guys still hear me? I've changed scenes and I've not done this before. I should have practiced. Wicked. So, thank you so much, Felix. I've got this picture. I want to send it over the internet. 2 questions. 1, what's the first layer? What was the top layer of the what was the top layer that I need for the TCP protocol to apply? Secondly, if I'm sending over the internet, what protocol do I use for that? So I've got 2 questions. Go on then, what do you reckon? Like a web page. I'm sending this like an image. I'm not emailing it. I'm sending it as over a web page to somebody. So apting as an answer, right? What was the acronym? Remember the top layer, there you go, is A. So A. So what's the thing that begins with A? ATIL is the acronym. ATIL, so close. ATIL, A-T-I-L. The A, thank you, Felix, application. The application layer needs to be applied to this. What kind of application am I going to send? What application am I going to send on here? If I'm sending this as an application layer, right? So what application? I'm sending it as a web page. So what was the protocol for web pages? Do you remember? What was the protocol for web pages? HTTP, Hypertext Transfer Protocol. So I'm going to say that this is going to be using HTTP. So my bit of data here, I've now applied HTTP. Or HTTPS, that's right. Well, let's say the picture of me, I'm not that personal about, I'm going to leave it public. So if somebody intercepts it, they can steal it. So now, we've applied the application data, and the application layer has been applied, HTTPS. Then it's passed down. What's the layer it's passed down to? What's the next layer in the TCP protocol? Transport, wicked. Now, does anybody remember what has to happen at the transport layer? In fact, maybe I should just demonstrate. This is where a connection is made. So a connection is established with the 2 different places, but also it's broken down into something. What's this data going to be broken down into? Packets, that's exactly right. I will demonstrate this. As everybody knows, I'm tremendously good at art and doing things like this. I will now cut this into 2 packets. Don't try this at home, guys. The scissors are sharp, so you know this could be the end of you. Right, there you go. I have now split this into 2 separate packets. Done. What am I going to need to put this back together again? What am I going to need to know about these packets? What do you reckon? If I want to put it in order, do I put it that way around? That way around? What's the plan? Yeah, I need to number them. So I'm going to do that now. I'll say this is 1 of 1. 1 of 2. And this is 2 of 2. And I need to say the size. So let's say we agreed the size. The size is whatever this size is, one kilobyte in size. That's how the cut's done. Okay. So now I've agreed that the numbering of the packets and the packet size, and I split it up. What's the next layer? So I had, first of all, I had application layer, where I stuck on the protocol of HTTP. And then I had transport layer. And transport layer allowed me to make the connection and break it into packets. What's the next layer? Maybe have a little clue. There you go. Whoop. Internet. That's right, internet. What, if I'm sending these packages through the internet, what are these packages going to need? I'm going to send these packets through the internet, right? I'm sending these packets through the internet. What am I going to need to send them? What are they going to need on it? Right? What am I going to have to stick, for these to get to the right destination, what do I need to put on these things? So I'm on the internet layer. Thank you, Brooke. You're quite right. The IP address. So I'm going to say that this is going to go to, I don't know, 17.34.8.250. So that's the IP address I'm sending it to right there. Now the problem's going to be, I should also write down where I sent it from, but for the moment, let's pretend that's not happened. So that's the IP address. What IP, do I do a different IP address on this one, or do I do it in the same place? Same, exactly. So the other one will also need the address, the IP address stuck on it, 17.34.8.250. So now I've got both of my packets in the IP address. I've done the internet layer. What's the layer underneath that? What's the last layer? So what's the last layer of the TCP? I'll give you a clue again. Where was I? Oh. Yeah, you're quite right, guys. So we started with, oh no, this demonstration's going off. So I started off with A, application layer. I then went to T, transport layer. Nope. T, transport layer. Then I went to I, internet layer. And finally, I go to the link layer. Anybody remember what I said happens at the link layer? So what's happening at the link layer? So the link layer is where the physical parts of the internet come into play. So this is where you might write down the MAC address of where it's going. I'm running low on space. Might be where it says where it needs to go for Wi-Fi and what protocol to use. This might be if it's saying over Ethernet, what protocol to use over the Ethernet. So this is the physical parts of the internet into play. So let's go through this. So I started with A, application. So application, which bit have I written on here was for the application bit? What have I written on here for the application? So on these, somewhere I wrote something on here for the application bit. Where did I put it? Where do you see it? Ooh, there you go. Where do you see it? That's right, Felix. HTTP. That's where I put the application protocol for this web page that or this image I'm sending over the web. So that's application taken care of. Then we've got transport. Transport. What did I do for the transport layer with these? What did I do? What did I do? For the transport, I cut them, I split up the packets, and then I numbered the packets. So 1 of 2, 2 of 2. Bear in mind, something right now, this internet thing we're doing right now, when I'm sending this video, we're talking millions of packets, and all of them numbered and then put together at the other side. Why do we do packets, by the way? Does anybody remember why I break it into packets? Why don't I just send the whole thing? Does anybody remember why we did packets? Maybe I haven't told you, actually, so I should say. If you don't break it into packets, and I send the whole image and it goes over the internet and gets corrupted, I need to send the whole image again. Bear in mind, let's say if I send an 8 megabyte image, a megabyte is a million bytes, so that's 8 million bytes. Each byte has 8 bits, so that's 8 ones and zeros. So if I send an 8 megabyte file, I'm sending 64 million ones and zeros. And all that has to happen is there's a little interference on your Wi-Fi or a little bit of a fault in the wire that makes one of those ones and zeros flip, and then suddenly you have to send the whole 8 megabytes again. And then that might ask you to do it again. So it's a real problem. By breaking it down, if you have an error with an individual packet, then you just have to send that packet rather than sending the whole thing. I'm going to read this one out, Josh. This looks solid. If you send it in packets and only one gets corrupted, it's easy to resend, exactly. But a whole file is too big to get corrupted. Spot on, Josh. That's an excellent answer. So it probably does take longer. There's a little bit of an overhead of 2 places. First of all, you have to write in the IP address. You have to put in the numbering. You have to break it up. It has to be put together again on the other side. Also, there has to be an error checking element to it to see whether it actually has been corrupted. And on the other side, it has to be run. It's more like A level, but it's worth knowing. But yes, much more reliable. Excellent answers, gentlemen. Thank you so much. And then finally, the link layer. And the link layer is where it's physically being sent along. Okay, so my packets are being sent through the internet. This is me demonstrating it. They're hopping along. In fact, they now go to a different place, go to a different place. 2 of 2 gets there. Oops, sorry. 2 of 2 gets there. 1 of 2 gets there. And now they're being received by the end user on the other side. What happens? Now the layer's done in reverse order. In reverse order. So what's the first thing that's going to happen if it's in reverse order? Which layer is going to happen first if it's in reverse order? So thank you, Josh. The link layer. The link layer. So the link layer is going to take it here. It's going to establish it went over the right protocols. It's going to establish that it got to the right MAC address, so they're physically to the right device. That happens. Boom. Done. What's next? Reverse order. What's going to happen next? So this is reverse order. So if it was A-T-I-L, now it's L, internet. Thank you so much. Internet. It's now going to, internet. It's now going to look at these 2 and it's going to check, did it go to the right IP address? Yes, yes. Excellent. It's probably at this level also, it might, it's then going to be passed up to the next layer, which is the transport layer. Whoops. Hey, what do you reckon is going to happen at the transport layer? Remember, it's in reverse, so what do you reckon is going to happen? Sorry. What do you reckon is going to happen at the transport layer? What's the reverse thing? Bingo! Thank you so much. It's going to get put together again. It's going to make sure that they're in the right order. That if there are any errors, if there's an error here, it's going to ask it to send that packet again. But let's say it got received without errors and we stuck that together again. And then the final protocol, what's the final protocol? Sorry, the final layer, if we're doing reverse order, is application. Spot on. So there we're on application layer. It's received as HTTP, so it's going to know that there's a body, there's a header, and it's going to read that data, and boom, you now have your own picture of Mr. Foster. Obviously, all the numbers and stuff will get removed, and then you see an image on the other side. And that is exactly how you're receiving this information right now, using those different layers. So let's go. So we've done that. This is talking about what we've just discussed, the application layer, what's going to happen on it. It's just going to a little bit more detail. The transport layer, how it's created the connection between the 2 hosts, breaks it, packets into it, numbers the packets, in our case, 1 of 2, 2 of 2, but actually it'd be like 1 of 6 million, 2 of 6 million, 3 of 6 million. The packets are reassembled when they've picked on the other side. And like I say, if a packet's been lost or is corrupted, it's the transport layer on the other side that will request it again. Internet layer. Sorry, 1 second. Louis is not on an invite. Like, I don't see him waiting to come in, which I thought was strange. I'll try and call him. Oh. There you go. Welcome, Lewis. And Louis, well, I'm trying to call him, see what happens. Right. Anyway. So, yes, at the internet layer, it's where it's going to put the IP addresses on, making sure it's getting put down the right layer, the right way. And then finally the link layer. So this is the physical part of the TCP bit. Looks at the NICs, the network interface cards, look at MAC addresses, puts them on. There's even the operating system device drivers for to make sure it actually does work. So when it picks up the internet on the other side, picks up those packets, it can understand